For lesson 10, we are going to take a look at graphs of functional relationships. So our first example here says that each graph shows the distance as a function of time. So that means that our y-axis is the distance and our x-axis is time in all graphs. One graph shows the function when Mr. Delo is driving in his neighborhood. The other graphs represent Mr. Delo driving on a major city streets and highways. Which description matches each graph below? So before we do that, there's a couple of questions we have to answer, and that is, the first one is, what is the slope of each graph? So if we look at this graph, we have 1 point given to us. So we have to find another graph or another point on this line. So it looks like they start at 0, 0, so I'm going to use that point. So I'm going to do rise over run. So my y value is 30 in that second point, and I'm starting at 0. So that means I'm going up 30, and then I'm starting at 0 and I'm going to 1. So up 30 over 1 would simplify down to 30. So the slope of that line is 30 right now. Then this one, if we start at 0, 0, we're going to go up and over. It looks like we're going up 40 and over 1. So that would be 40 over 1 for rise over run, and that simplifies down to 40. And then this one, looks like I'm going up 60 and over 1. So rise is 60, run is 1, and that slope would be 60. So what's the slope of each graph? We just figured that out. What does the slope mean in each graph? Well, I wrote them as rise over run. So the 30 represents how far we're going up, and on our y-axis, going up is our miles. So that's 30 miles. And the 1 going over represents our hours, our x-axis. So that is 30 miles per hour. So what does the slope mean in each graph? Well, it is representing the speed of his car. And then we have to match the scenarios with the graphs. So one is him driving in his neighborhood. If he's driving in his neighborhood, that means he's probably in town, and he's going to have to go slow. So I would say graph A is the neighborhood. Then he's got major city streets and then highways. So highways is where he's going to go the fastest. So this one down here at 60 miles an hour would be the highway, and going 40 miles would be your city streets. All right, now we're going to take a look at this graph, and it says it represents a person tossing up a basketball and letting it bounce on the ground. Describe how the graph represents this situation. So the person is standing, so that's why this graph is starting here. It's the distance from the ground on the y-axis. So this person is standing and then tosses it up a little bit, so that's why it goes up. And then, of course, a ball hits the ground, and it bounces back up and comes back down and hits the ground again, goes up and then hits the ground again. And each time, it's losing its momentum, so it's not bouncing as high each time. So this graph will continue on for a little bit longer until the ball stops bouncing. So that is how the graph represents the situation. The bounces of the ball that are getting smaller with each bounce. Okay, now we're going to look at this graph, and it says students in Mr. Blanco's class have 3 weeks to complete their science projects. These graphs show how much of the project 2 students have completed each day during the 3-week period. Describe what each graph shows. So let's look at Lynn here first. The y-axis is the amount of science project he has completed, and the bottom, the x, is how long in weeks. So it looks like, obviously, he started with nothing done at here, And then he worked continuously at the same speed until towards the end, when our line continues to go over, but it's not raising anymore. So I'm going to say that right in here somewhere, Lynn finished his science project. So he continuously worked on his project until it was completed, and then he had some free time at the end where he just had to wait for time to pass until the due date. Over here, Amy started with nothing done. And it looks like she did a little bit because that line is raising up. So she worked very little until the very end when all of a sudden her line jumps up and she's got more of her science project completed. She did the opposite of Lynn. She took her free time at the beginning and then hurried up at the end and finished her project. All right, now we're going to be given a graph that's kind of broken up into different little pieces. And it says that the graph shows the daily sales of frozen yogurt at a new store during a 6-month period starting on opening day in April. Describe what is happening in terms of this situation for each section of the graph. So part A here started when they opened the store, so they had 0 sales, and it went to here. So part A, it looks like they had continuous sales throughout the day as time passed. So sales were continuous throughout the day. They kept getting more and more people coming in. Sales were continuous. Then if we look at section B here, our line is steeper. So that means our sales increased. And then part C, time is passing, we're going straight across, but our sales aren't going up or down. So here our sales stayed the same. And then part D, sales were decreasing, maybe towards dinner time. People weren't coming in to buy frozen yogurt because it was getting closer to dinner time. So sales are decreasing. And then for our last piece, our sales stay the same after part D, but it doesn't ask us to describe that. So I use the word continuous up here for number 2. I want to change that. I want to say they increased. They were increasing as time passed because that line is going up. So your sales are increasing there. Increased the green part, they were still increasing, but they increased faster. And then part C, they stayed the same for a little while, and then part D, they decreased. So we're looking for those vocab words that indicate what was actually happening there when you write out piece by piece. All right, for this one, we have to write our own situation here, kind of like what we just did with the yogurt sales. But this time we're talking about the price of gasoline over time. So the first piece, we're going to go piece by piece here. The first piece, our gas prices stayed the same. So I'm going to type this. It's going to be a little bit easier and quicker here. So gas prices stayed the same. Then looking at the next piece here, right here, the gas prices decreased. So then we can say gas prices decreased. Our next piece of line is staying the same. It's not rising or dropping. So our gas prices stayed the same again. Then our line shoots up. So we can say gas prices increased at a quick pace. And then we have a straight across line again. So then they stayed the same until they dropped. That line is dropping, but it's not dropping too quickly. It's not too steep. So until they dropped a little, then they stayed the same for a while at that last line going straight across. So you can be as creative as you want here and with your stories. What I'm looking for is that you're telling me that they stayed the same, they've increased, they've decreased, quick pace, maybe decreased just a little, things like that. That's what I'm looking at, but you can add as much detail to your story as you want and be creative with them. All right, and then our last one here, we're gonna have a story and we have to make our graph. So Angela and Lori are hiking a mountain. The beginning of the trail is not too steep and they start out at a quick pace. So we have to draw the graph and we have to figure out what's going on. Well, they're hiking a mountain, so time is gonna pass. So time is gonna be our X. And this would be like the height of the mountain or height on the mountain. It's hard to write sideways there. And then I put this analyze it over here, and in red and blue, those key words popped out there. Those are the words that help us decide how we're going to write the graph. So the beginning of the trail is not too steep. So we're going up, but we're not going up too fast. And they start out at a quick pace. So they're going up, and then they stop and rest for several minutes. So they're going to rest. So a straight across line, time's going to pass, but they're not going to change on the height. They rest and then they climb a steeper part of the trail at a slower pace. So now they're going to go up, but they're going to go quite slow up until they reach the highest point on the trail, and then they rest again. So then we're going to go straight across at a constant rate. Before they climb down at a constant rate faster than they climbed the mountain. So now we're going to go faster down. So breaking that story up in order to make each piece of the graph. So I know my drawing's not the best because I couldn't zoom in so that we could keep the story on the same page, but you kind of get the point. So you're breaking it up piece by piece, looking for those words that help you indicate, is it going to be a steeper line, a straight across line, or not so steep. So you get to have kind of fun with these and be creative as you're, especially when you're making your stories.